Chris, I hear you're flying solo.
Yeah, evidently Brianne is going to be on toddler duty, so not a problem. She was going to be my silent partner in this. She certainly helped with a lot of the research, and we have a little treat for everybody at the end that she's taken part of. So I totally understand. My daughter is now 16, so we're past the point of toddler duty, but I've made sure she's quiet in the background. So.
Great. Where are you physically located?
I'm like Justin, West Coast. I'm in San Diego. Nice sunny San Diego. It's been hot.
Say, no wonder that sun is coming through that window behind you.
Right. Yeah. It's pulling in the tail end, I think, for everybody else's day, but yeah, we're still going here.
Great. Tell everybody what you do for Sonatype.
Sure. I'm with the customer success team here at Sonatype. I know a number of my teammates have already gone today. I've been with Sonatype for about 3 years now, so this is my second user conference. But I think when I officially started, we had maybe 3 or 4 customer success members, and we're now up to like 20, 25. So
yeah, it's astounding, isn't it?
Right. Yeah. So it's surprisingly finding myself on the senior end of that team, but I'm glad to be here and be able to share what we've learned over the years.
Great. Let's get started then. If you will share your screen, share your deck, I will go to the background, and we will be here if you need some help.
Perfect. So let's get this going.
It looks good.
Perfect. Thank you. So again, I'm Christopher Tolo, customer success, and Brianne is attributions are on here. So hopefully she's listening. So customer success is a little bit different than the rest of the organization, or maybe even what some of our customers are used to. We're kind of a combination of coach and advocate for our customers. So we help guide them through the initial deployment of their Nexus products. Later on, we then do these account reviews where we keep that flow of two-way flow of information between our customers and the rest of Sonatype. So one thing that we see quite often during the early part of a customer's journey is we see some common primary desired outcomes that they share. This is usually they want to start with a goal of scanning everything to get a baseline of all of their applications. Next is some form of SBOM, where they're doing a bill of materials of all of the components that are in there, whether for internal or external compliance. Next, once violations are starting to roll in, we look at getting them integrated into their ticketing system, so you can get those violations reported back to the developers. And then once the developers have that confidence in the above process, they're a little bit more easier to accept management of that government. So either auto enforcement or some sort of blocking of those components. So each one of these goals does require having a good integrated lifecycle scan in that application build process. And so that's kind of what I'm going to focus on today. So, so for my agenda, I'm going to start with an overview of the Nexus Intelligence. This is basically what makes Sonatype unique for those who need it. I'm also going to move into how we identify the open source components within your application. We're going to do a quick review of the different integration points, and then we're going to specify doing a scan at the build stage. I'm going to go over a few key language supports just so we can understand what the differences are between those different types of languages and how we would want to scan, and mostly just so we can deliver some value to the pipeline, the best value for that. So Nexus Intelligence is about definitively identifying and providing accurate metadata to the open source components that are being used. We focus on open source in your applications and not on any of the security vulnerabilities with the rest of your code. So in order to do this well, we catalog all the open source components available in the most popular open source ecosystems. These are the components that are found in public repositories for each of those languages, like Maven Central for Java, NPM for JavaScript, Nuget for .NET applications, and so on. This cataloging means we do a binary fingerprinting of each of these kind of components, and in some cases their contents as well, so that we can precisely identify them. This is not really something that anybody else does. So furthermore, rather than subscribing to a single data feed in the security vulnerabilities, we create our own. by pulling in security data from throughout the internet, right? This includes things like the NVD, GitHub pull requests, security advisories, Google searches, and more, right? A whole bunch of stuff. The data is then processed through some sophisticated algorithms before it's hand reviewed by our data security team. And then these are queued up to our security researchers who produce comprehensive security data that you see in the tool. I recently learned about the Central Security Project that we are a part of. It's a collaboration with HackerOne, and it basically allows public researchers to report additional security vulnerabilities that they discovered so that they can quickly be vetted and added in particular to our products so our customers can benefit it. But this type of collaboration, around bug bounties and stuff is a great way of getting additional information into the tool. The last point I want to mention here is secondary expansion. This is always not always clear with our customers, but this is where we precisely target vulnerable classes within components in libraries out there, and we locate every other project that exists that contains that similar class, right? So, this kind of research allows us to greatly expand upon known vulnerabilities across the entire ecosystem, and then precisely report those vulnerabilities within the components that you're consuming. So this is, again, a part that really differentiates from anybody else. So with all these together, this is how Sonatype eliminates all false positives to our developers and gives us that kind of accurate information that we can automate against. Similar to the way we catalog components from public repositories, a typical lifecycle scan is a binary fingerprinting of the components that are within the application. These fingerprints are aggregated and then compared with the data that we've cataloged from the public repositories, and allows us to uniquely identify every open source component used. The fingerprints of custom components, or those that are not stored in the public repositories, are not going to be found in our database, right? So we're not going to know anything about those. And since everything is done with fingerprints generated during your build scan, no source code is harmed in this process or exposed in this process. So no worries there either. So to assist with some common issues that we're going to see and talk about later, I want to mention the index goal for the CLM for Maven plugin. This is used to generate a dependency index, right? And so this is basically a list of all of the direct and transitive dependencies that are referenced within the project POM. And this generated modules XML file contains the information that's incorporated later in a IQ scan evaluation. So in particular, in the final scan of the CLI tool, CI tool, those components are actually hashed and fingerprinted through that M2 cache, and then that way we still enforce the accuracy of exactly what's going to be used in your product. So our project, and so this way is kind of like a hybrid. And then the other end of the spectrum is the manifest scanning, this is where we're doing a project build manifest to understand what supposedly is going to be used in the final build. This method is not as accurate as binary fingerprinting because it really only gives us details about what's supposed to be there, not what actually is. And so we don't have quite the confidence that we do with our binary fingerprinting method. But it does have some use cases, and in some places this is very useful and it's required, such as when we're identifying Python components, for example. Or when we're using the IDE or open source or the source code, or we're using that Chrome browser I mentioned before. This is basically when the components themselves are not available for fingerprinting. We just have the location of the component. And so this type of scanning is usually limited more for like the further left side of the SDLC when we're talking with the developer. So let's take a look at that. So I'm not going to spend too much time on this slide, but I do like it because it represents a good overview of all the points that Lifecycle can scan and be integrated into your software development lifecycle. Everywhere you see that little L icon is basically where we can either set up an automatic acceptance or reporting gate. That's typically done more on the right side. And then the other side would be on the left would be more for delivering clarity to the rest of the organization on the open source that they're using, so that way developers can make good judgments on that. So I recently heard in a talk from a CTO where he was saying to his developers, he was saying the job of building security is every developer's job, right? And I thought that was great, but I also found it interesting because not all developers are security experts, right? And so, quite often we don't really want them to be, and that's why delivering the relevant information to that kind of lower left quadrant here is a process that's so important to us. It also tends to be the hardest part to deliver well because it requires either that high-level corporate sponsorship where they're mandating it, or a difficult socializing of adoption where we're telling everybody about it and trying to get them to buy in. And often it requires a good helping of both, right? And so that's kind of some of the challenges that we're dealing with. When we're looking at the integrations themselves, it's important to understand that the Lifecycle solution is not a single piece of software, but a centralized policy server, the IQ server, with a number of additional integration points, such as what Justin had been showing. So the CI integrations in particular are for application scanning, gating, and typically run during that build process. Whereas the developer tools are more for surfacing that governance data further to the left. And as I mentioned, getting that developers to use these tools would be ideal, but it takes a significant amount of time to adopt since they have to install and use those plugins that we provide. Once you have the scan data, we can start looking at doing the reporting tools to get that automatic data into the ticketing system that the developers are using. And that's very highly effective for driving adoption when they have that information in front of them. But this also typically takes a while to configure or script if need be to be effective. And it also still requires the scan to happen automatically somewhere, right? So that's why we typically focus on what we can control, which is the build process. And so we're going to dive into that now. I think my slides might have reset. There we go. Sorry about that. So here we have actually 3 primary tools for running a scan application during the build, right? So and each one is used for a different reason in a different context. The native plugins that we have are installed directly into the build tool, and they're really the easiest way to run a scan, as many of the parameters can be set as environmental variables and scaled out across all of your apps and orgs. So you can use them to either scan the final build artifact, or you can use it to scan the workspace in general before packaging the components. In particular, for the Jenkins platform plugin, we've also rolled in the process for deploying to your Nexus repository while handling any staging functionality. And it looks like some of the GitHub pull requests that Justin was mentioning. The plugin also includes support for Jenkins pipeline, which is a great way, and that's also with the Jenkins file support to centrally manage your scanning configuration across your entire org. So definitely a great tool to use. The CLM for Maven plugin is an extension of Maven, and it can be used to run a scan as in settings directly into your POM file. And so you plug in the evaluate goal and have it run during your build process, and a scan is made and being delivered to the IQ server. So it's a great way to automate that. There's also a lesser known option in that plugin, the index goal, that can be used in conjunction with our CI tools, right? To prepare basically the index goal prepares the dependencies to be analyzed as a completed BOM, right? And so, and then the CI tool will actually run the scan. So the third option here is our command line scanner, and we kind of refer to that as our Swiss Army knife, right? Because it can be used anywhere that you can run a Java jar. This is often the case in CIs where we don't have an official plugin for, or basically anywhere you want to script out a scan. So one nice feature to this one is you can point directly to a folder, scan the components found within it, and it comes handy for builds that where items are being pulled out of context or obfuscated packages where we need to focus on just a particular folder of components. So it also has, we also have packaged this CLI into a public Docker container to make it easier to pull down in pre-configured environments. So it's basically a ready-to-go Java environment where you can run the CLI at any point. So also very cool. So scanning Java is our bread and butter, right? So this is what we do, but you know, among a lot of other things. But there are a few quirks that are worth mentioning about it. So with any of the scanners, you can basically use a post-build artifact from Java as the target. These are typically what you are planning on deploying to you know, whatever production. So whether it's a war, EAR, or tar, etc. So you can also run a normal build and add a post-build step, you know, with your different CI plugins or whatnot, and have that scan be run to that point, right? And you typically want to do this before you're deploying to the repository. So this is why you have like a quality gate in place, and if your component is going to be failing your policy at that point, you're not deploying it out to the repository. In most cases, this is a process whether you're using whatever tool that's available. Now, regarding scanning jars, the reason why our scan above is successful is because all of the open source components that we're scanning are located within that built artifact, right? So this is how Maven projects are deployed. The scanner can do a binary fingerprinting of the components and tell you exactly what's in the application. Custom jars, you know, are often just your own code, your own source code, and they don't contain the open source dependencies that might be referenced in that, you know, POM file. So the scanner is only going to report on the components that have been included in your jar, and you know, of course, there are some exceptions to this, and that's when you have like a jar with dependencies or an Uber jar. But for most cases, scanning a jar would not produce any results unless you're scanning an open source components directly, such as like your M2 cache folder or a folder full of jars that we mentioned before. It is worth bringing up here similar match, so that you know, that's an additional way we identify open source components. In the Nexus Intelligence section I mentioned earlier, we do have some cases where we catalog not just the open source components, but their contents as well. This allows us to identify components that have been modified, right, by comparing the internal classes with those of their components. And if we have enough of the parts that we can match, we can confidently tell you that what you're scanning is this component, even if the external hatches don't match. This is important if you, you know, when you're, it's important for you to understand when you're scanning a modified component, because there might be some sort of security risk involved with that, right? Somebody put you know, some malicious code in there. There also could be legal risk with modifying open source components. I think Adam was talking about that earlier, and it's definitely involves some sort of tech debt. So again, when you're modifying components, it's an important thing, and the similar matching is a good tool for that. So now one instance where this happens is when you're scanning an Uber or a shaded jar. And more often than not, this is going to produce results that you're not expecting, right? A quick summary is an Uber jar is also known as a fat jar with dependencies, is a jar that embeds all of its dependencies within it, right? This is often done by unpacking all those dependencies and then repacking them into a single monster jar. A shaded jar is similar, but it also includes renaming some of those packages before putting them in to avoid naming conflicts that might happen with those Java jars. Our data processing would not be able to recognize, or would be able to recognize all of the internal components, but ultimately wouldn't be able to match it against known components because it's just a big mess of stuff. And so the results are often you know, something that's unknown, right? We get returned back, and we're not able to identify this component. But fear not, all is not lost. To help with the identification, we have a couple options, right? So first off, you can use the Maven index goal that I mentioned earlier when you're building the jar, right? So when you're building that Uber jar, this includes a modules XML in there that can be later picked up by the CI, and that would basically understand what's in the jar, right? And that helps with the the scanning part. So this is kind of like one of those IKEA picto guides that, you know, for the scanner to help it understand, you know, what are all the parts that are in there and how to make sense of them. Another option that you could use is that Maven copy dependencies command to load the dependencies into a folder and then use one of your scanners as to target that folder. So this is a very common process when we see that we'll talk about a little bit later on. But you know, basically you can use the CI or the CLI scanner to target that folder of components. And then finally, you can also use the Maven dependency plugin to unpack those dependencies into a directory and then use the command line scanner similar to above. So I have some links here that you can use to find more information on that. So these might take some extra steps other than just straight scanning of the jar, but they're going to give you the most consistent and accurate information for your scan. And so that way you know what is exactly in your Java application. So next up is Gradle and Android packages. Now they both use Java components that are from Central Repository. The big issue with Android, however, is that our scanners can't open or understand the components that are within an APK file that the Android typically ships in, right? So, and this is because the Android build process obfuscates the contents by converting it into a devuc executable, which really doesn't look like anything of the open source that was initially used, right? And so even more so than those Uber jars. We can get in front of this issue by running the lifecycle scan earlier in the build process, however, right? And so this is before those compilers do that conversion. The Maven plugin, again, can be used with the evaluate goal. If you're building via Maven, if you're using something like Gradle, you can use a Maven copy dependencies and use the CLI again to scan the folder of those components. So that's typically the most common way that we see customers getting around that and being able to scan those. So again, that's just getting in front of that as opposed to doing your typical post-build step. So to scan a Docker image, you currently need to save that image to a tar file, which can then be scanned with either the CLI or the CI tools, right? So both of them have features that can do that. Both of these scans are also smart enough to go in layer order to pick up the changes in the final image by excluding those overwritten files. And so that's important because then you'll only get what you actually had in the container. One important observation here is that our data will be focused on the open source components that are found in the application layer. And so while we can scan the whole image, you would be getting the same value really if you just scan the application earlier in the process and then gated it there, right? Rather than waiting this late into the build phase. By waiting this late until you built the image and you downloaded it and you scanned it, and to break the build, you could be wasting a lot of expensive resources that you could have stopped earlier on along the process. So either way, this scanner still plays nicely with other tools. So if you have other tools that are looking at the rest of the image, you know, that's fine. And then the IQ is going to give you the excellent data on the application layer. And we do also plan on expanding our container scanning offering in the short term. So I think there's some important things to stay tuned for on there. So JavaScript. So a quick reminder regarding JavaScript, or any other language for that matter. While we're identifying components, we are identifying components that are coming from the NPM registry, right? So according to Wikipedia, I looked up earlier, NPM registry was started around 2010. So there may be some exceptions, but anything written in JavaScript before this is probably not in the registry. And so we most likely won't be able to identify it. And from working with a lot of customers, there's legacy codes out there that we're just not able to identify. So on the plus side, any hackers would probably be surprised that you're still using that. So maybe you'd be okay. So now, kidding aside, you'll probably treat these components just like your own source code, run some sort of dynamic analysis on them until you can move it into something more modern and useful. So any component in NPM that you're using, we will be able to find and report on any vulnerabilities that are in there. And this is great for things like the firewall in our Chrome plugin. However, it could be a little difficult when building an application, right? Because unlike Java and Central, packages from NPM are rarely used in their entirety. The component is often unpacked into the node modules folder, and those specific JavaScript files are ultimately deployed within the final application, right? So they're pulled out and used. And so running a straight scan against the workspace will often result in just this confusing mess of node module stuff. So another common issue that we see is that JavaScript packages are often either minified from the official version, or they're merged into other packages into this like single package to simplify deployment. Doing this actually makes it impossible to detect that original open source Java components or track any changes made to that during the process, right? And so, that's not great. And then the other part is to make it even more fun, NPM pulls in a ton of additional components that are often development dependencies, and that they ultimately won't go in the final application anyway. So just scanning that node modules folder is really not that helpful. Our developers here at Sonatype ran into this issue scanning our own products, and so they decided to start leveraging a web packing tool. And this basically isolates the JavaScript components that they'll be in the final application so that they can scan them directly before they do things like minifying and combining and all that stuff. So we've also seen other customers have similar success in isolating production components, using things like the npm install production, and that allows them to just pull in the things that are required for production, as opposed to all those developer dependencies. And then I know the npm project has also recently released within the last year or so npm CI, which looks promising, even though I haven't really seen too much action on that yet. So there might be more to come on that. And then a final note, I wanted to mention the difference between npm components and a-name that you might have seen in our product. A-name stands for authoritative name, and it is some of the data science magic that we do in the background for identifying all of the bits of JavaScript that are found across all the multiple ecosystems. So it's like if random Java classes were just pulled out and dumped anywhere. That's kind of what we get with JavaScript. And we want to be able to identify that and let you know the source of where it comes from, right? But this is really tricky. And so in a lifecycle scan report, we will identify all those individual JavaScript files and roll them up into an a-name component. But when we're looking at, often looking at those components in the CIP or the component information panel, we'll actually display them on as npm components that they're found from where they're found. So that simplifies that process greatly. So Nuget. So Nuget packages are basically similar to JavaScript. The packages themselves aren't used. They're extracted. Those dependencies are actually then pulled and packed into a folder. We do often sometimes see the case where there'll be a vulnerability on the package itself. They'll be reported in the component information panel, but the files themselves actually aren't being used, right? The files that you're used don't have a package. So luckily, because of the precision that we have with our scanners, we're only reporting on the things that actually have those DIL files that you're using that have vulnerabilities, right? And so that gives us that precision to be able to target those specific vulnerabilities. So we have seen some customers where they're like, hey, it's showing this package, but that package is actually not being used. So it's important to understand that when we're reporting on the things that you're actually using. Nuget also deploys using similar matching. This, for the most part, works pretty well, except for when you have DILs that are in many other packages, like hundreds of other packages. What ends up happening is our processors are just not able to determine who the original source is for that. And so those will often show up as unknown packages when you're getting that. So seeing things at unknown doesn't mean that we've never seen it. It just means that we haven't been able to identify where it comes from. But we do still have all of the security data that's associated with that, and we would report it appropriately when that comes through. So that's something to keep in mind with Nuget. Also, you may see a-name pop up in Nuget. It comes up, JavaScript's basically found all over, and you'll see those come up too. And so we'll have sometimes customers saying that, I'm scanning Nuget, why am I seeing JavaScript? And that's basically why. And again, you can do a similar process where you're using either the CI plugin, the CLI, or the Chrome extension to identify these. So the nice thing about the Chrome extension is it targets those specific Nuget packages. So it gives you that big overview of the entire thing as opposed to those individual things that you might be using. So the last few I'm just going to kind of quickly go through. We do support RubyGems. This is supported in Firewall for identification, license, and security vulnerabilities. That Chrome extension thing would be awesome for this, right? Because we don't really identify it at this point within your actual application. So being able to pull them in through the firewall, gate it like Chris Carlucci mentioned earlier is great. But then even doing the research and stuff, you can use the Chrome extension for. And that'll give you that information in a very easy to consume way for your developers. And then Python is pretty quick and simple. This is an early example of our manifest scanning that we're starting to implement. And this is where you're doing a pip freeze to a requirements.txt. And at that point, we recourse through that requirements text to identify the information on those components that are being declared there. So you just use the CLI scanner for that and should work great. So. And that pretty much concludes. Here you can actually find, this is what Brianne's little gift to you guys. Everything I talked about here is available as a technical guide for lifecycle scanning, now available on the websites directly. You can go to that link here and pull all this information, not have to listen to me ramble. So, but I do appreciate you being here today, so thanks.
Chris, thank you so much. I was questioning when I saw the listing of the title, it said comprehensive. You actually did a very comprehensive overview there.
Thanks. So,
when you're talking about the stuff that Bria is providing, what format is that in? Is that web searchable? Is it PDFs? What are the guides?
Yep, they're basically, we have a number of guides on our my.sonatype.com website. If you go to that site, that's our centralized portal, if you will, for everything that is Sonatype at this point. And once you're there, there's a guide up top, and you should find it published there. So I think she actually published it this morning. So if the index hasn't picked it up, it will soon. Or this link will be available. I'll make sure I share this deck out.
All right, thank you. Derek just walked in. We're going to call it a wrap.
Perfect.
Thank you so much.
Yep.
Bye, Chris.
Bye.